Welcome to another, is it on? Yes. Welcome to another exciting readings class. Some students apparently are taking Dr. Munden's course. I have to be careful not to call him Ryan because I'm recording and I want to be formally correct. And Dr. Munden apparently is having you all do printed circuit boards, which is very excellent. Now, when you are using batch PCB to do your circuit board and you would like to share your design, the only way in which you can share your design is to make the design public. Once you make something public on the internet, you are publishing it. When you publish your intellectual property without a patent, it becomes a positive barrier to patentability. So what this means to you, the batch PCB user, is that you may not share your designs on batch PCB by making them public if you think you have intellectual property that you thought you might like to patent eventually. This is a very important aspect. There is no way to share designs for targeted review. That is to say, let's assume I have a design and I just want to show it to George. I can't do that. What I can do is I can take the whole thing, the Gerber files, pack them up, upload them to Dropbox, then I can share them to George for his review, and it does not constitute a publication. If, on the other hand, I show them to the entire class and I don't make them sign a non-disclosure agreement, that constitutes a publication. If I leave it on my desk and somebody happens to walk in, that does not constitute a publication. If, on the other hand, I make a mimeograph, copies, and I disseminate it to perhaps a couple or 10 people in a small workshop, that constitutes a publication. So if I take it and then say, well, I'm just handing it to you for your personal review, keep it to yourself, that does not constitute a publication. If I make you sign a non-disclosure agreement, then for sure it doesn't constitute a publication. But if you verbally agree not to disseminate the material, it's not a publication. If, on the other hand, you lied, and then you proceeded to publish it, then everybody who signed the non-disclosure agreement is off the hook, and it constitutes a publication. This is the essential Achilles heel of the non-disclosure agreement. If everyone you've shown your project to signs a non-disclosure agreement, but just one person publishes it, then none of the non-disclosure agreements are in effect any longer. And this is a very big deal. The other problem with non-disclosure agreements is, and this is a big problem, how can you prove who told what who when? How do I know that you didn't already think of the idea? Suppose you had this idea about building a transistor, and I said, I've got this great idea, but before I can tell you, you must sign the non-disclosure agreement. So you sign the non-disclosure agreement and say, I found a way to build 3D transistors. But I've already read about that. I already knew about this. This was my invention. Well, you signed the non-disclosure agreement. You can't tell anybody now. Well, no, I invented it. I have it documented in my notebook. It's printed here in IEEE computer. Everybody knows about 3D transistors. Nothing new there. What are you talking about? That's not an invention. Nothing new. So now the NDA becomes very complicated. So who told who, what, when? That's very complicated. If you're a venture capitalist, if you're an angel investor, if you're, like me, the president of IACT, and you're exposed to many strong-willed individuals who could be called kooks, right? Who all think that their invention is the best thing since sliced bread. The one thing you don't want to do is sign a bunch of non-disclosure agreements, because you can never keep track in your head whose non-disclosure agreement belongs to who and how long they are in effect. So I never sign non-disclosure agreements. I used to, but I don't anymore. That's it. I'm done. And neither does my business partner, by the way. Never signs a non-disclosure agreement. He's a bona fide angel investor. So, as a result, NDAs have very limited utility. I don't recommend using them. And by the way, a lot of people disagree with me. So that's a very interesting point. While that is my opinion, okay, other people have their opinions. And some people say, you gotta say these non-disclosure agreements are very important and everybody must sign them. And they will not function unless you sign. I say, well, I'm the president of IAC. I got too many inventors telling me inventions I can't keep track in my head. Therefore, I won't sign any non-disclosure agreements. And most investors are that way too. But I have seen some angel investors who have come and done presentations here on campus who say they don't have any trouble signing a non-disclosure agreement. But 9 times out of 10, they refuse. So if you're looking for money from people who are angel investors or VCs, you got to figure out what it is you can tell them. Just enough, maybe not too much. Keep your secret sauce. Keep your trade secrets. Maybe file your provisional patents. Nail down the intellectual property first before you tell them the stuff. Then you can tell them once you nail down the intellectual property. So if you've got an idea and you think it's got value, you got to be very careful about batch PCB and publishing stuff for others to see. That's just no good. I'll give you an example. Let's batch PCB now. Okay. And I'm telling you about this because it's relevant, right? Because there's a bunch of people here who are using batch PCB. And batch PCB has a share facility that lets you publish your intellectual property. But just because it lets you doesn't mean you should. Because once you publish it, it puts it into the so-called virtual marketplace. And now people can take your designs, they can pay for them, and you're offering something for sale. Well, the patent office says if you're offering it for sale and you haven't filed the patent, that's a positive barrier to patentability. Now the clock is ticking. You get about a year, and that's just for the U.S. patent. You're already prevented from an international patent. In this country, you get a year leeway after publication to file for the patent. But for Paris Convention Treaty, which covers all the member nations, the Japanese patent system, the Canadian patent system, the Chinese patent system, none of those people will accept your patent after you've published it. You don't get the year. So that becomes a positive barrier to patentability on an international basis. So now you've lost the ability to nail down your IP, your intellectual property, just because you hit publish and it went into the marketplace here. And all you wanted to do was share your design with Dr. Munden so that you could have your homework. Better to upload it to Mentor where only he can see it, and then you're fine. That's not a publication. Send it to him as an email attachment. Or you could even send it to me. Professor Lyon, what do you think of this idea? That's okay. You're doing it for evaluation. That's not a publication. Showing something to somebody for evaluation is not a publication. Showing them your notebook, your secret sauce, your trade secrets, whatever, that's not a publication. So it's so important to know what is and is not a publication. Eckert and Mauchly were called into a court proceeding against, I think it was Honeywell. They had the Eckert-Mauchly Computer Company taken over by Univac. And Univac was making computers. They had the patent on the computers. Well, along comes John Neumann, and perhaps more than a year before they filed the patent, he decides to mimeograph information about the ENIAC computer and disseminates it in a workshop. Well, the court rules in the 70s that that was a positive barrier to patentability. And so it takes years for these courts to do rulings sometimes, but there it is. And so publication is so important. That's such a critical part of patentability. So there you have it. A whole bunch of people have published stuff. It looks like it's all being, I don't know, freely disseminated, perhaps for a fee, but essentially disseminated, offered for sale. Now if I sign in, I have access to my designs. Designs which should not be published. Am I save your password? Am I in or not? Yeah, I'm in. So now let's look at my status. I have a PCB waiting for DRC check. There's a DRC bot available. That's DRC stands for Design Rule Checker. if you're failing your DRC, it's so important if you're failing, then let's see, in process, what do we got? Oh, this is what they're producing. They're panelizing. My account, let's see what we got. So now here is a DAC. It passed. Here's one that didn't. That failed. Now that came from SparkFun. Here's one called the Fritzing test that passed. Let's take this one that failed. It says here it's layers. I can edit it right on Batch PCB. I don't even have to go back into my design tool. And now let's assume there are certain layers that I'd like to turn off. You know, here you see this checkbox, publish this design? That you can't check, because that would stop you from being able to get a patent. If you did publish the design, then effectively you would not be able to file a patent internationally, and you'd have 1 year before you filed a provisional patent application in this country. It's a very interesting point. Just this checkbox. And it doesn't even have to be checked for very long. Just a moment. Right? You could say, but I published it for a minute, but then I unchecked it because I realized the mistake I would made. Too late. Too late. If we can prove that it was on the web even for a second, it's published. Right? Because you have unrestricted access to the design, or at least the ability to buy the design. That's a publication. So this is a very interesting point. Don't check this. See this? Don't check here. And it's very bad. I mean, because it's so easy. So let's see if I can update the PCB. Now if I update it, DRC failed, I should be able to look at these layers. No image rate. See, if there's a problem in this layer, I could keep it out. Now if I keep it out, and, well, I got nothing left. Let's try this layer. We'll try this as, we'll identify it as top copper. And we'll save. I don't have enough layers here. And then that's why it's failing. So now it's queued. So I didn't even have to resubmit. All I had to do was change which layers are kept out and which ones I'm keeping, and I can use that to try and diagnose which layers are giving me a problem. About a minute later, I can go back and refresh, and it should change the status, and the status has failed. So I got sort of instant gratification on that. I mean, it's fairly quick, and it lets me, you know, do the design pretty quick. There's, you know, better ways to disseminate your stuff. So suppose you said, I've got a design, here, it's my audio shield. It's been updated now so that, oh, this one's empty? Really? How about this one? Ah, there it is. So now here's a way to disseminate it to your instructor. Upload it into your homework assignment, you know, pack it maybe into a zip file, let Dr. Munden know, here it is, and you've uploaded your homework. Now that's not a publication. Then you can have all kinds of interesting intellectual property up there, and it's in Mentor. So that homework presumably is accessible by you and to your instructor, and that's sufficient. You don't have to publish it. But presumably you won't do this until it's, how you say, finished? Probably you would want it to be finished, right? Or else it's bad. That's bad. Here's more information about getting things through Batch PCB, which you may or may not need. Have a CAM file here. That CAM file is not the same CAM file as a Gerber 274X CAM file. And the reason why is because the layer naming convention that the design rule check bot uses is different than one that might be used by, let's say, Seeduino Seed Studio. So everybody has their own thing. If you went and said, I have my drill template in a .dri file, well, Batch PCB thinks it should be in a .text file, txt. So if you got the wrong suffix, you have to make sure the layers have been correctly identified for the batch PCB bot. So batch PCB bot interprets files based on file names because it doesn't know. So you have to make sure you know which layers go where. I sent, I don't know how many communications to my students about this to try and get them to understand about CAM files in the DRC bot, because it's a big deal. You're going to have, I'll call it a negative printed circuit board design experience, and you'll get the impression that it's really hard when it really shouldn't be, and nobody wants that. So there are these interesting how-tos that give us information about how to deal with certain fabricators that are popular, like Batch PCB. It's a very popular fabricator. And here's somebody who says he's created his own shell script. And the shell script gathers the files, makes sure they're named properly. He uses his own SparkFun DRU file, the design rules. This is one of the things about Ultiboard. Design rules are entered one dimension at a time into a complicated graphic user interface. Whereas in Eagle, the design rules are just put into a DRU file, which you can open and then auto-route against. And that way, all the spaces that are required, if you're working with only... See, Batch PCB may say, okay, today we're just working with 10 mil. But Ultiboard might say, okay, we think 8 mil will work. So if you've got the wrong design rule for the spacing on your printed circuit boards, the DRC bot will just kick it. It's not going to tell you why. It'll just say, sorry, failed. You got binary information. It either passed or failed, and you don't know why. But if you've got the DRU file in Eagle, and you're doing an autoroute against it, and you do a check, it points at the place where there's a problem. And it says, this is the issue. Fix this. So ostensibly, you'd like a couple things. First, you want a design rule file that it gives you correct designs that the DRC bot will check, and second, will give you hints about where the problems are, if there are problems. And the third thing is you want to make sure you've got the right CAM processor going. That's so important. If you have the wrong CAM processor, you're sunk. Really sunk. Now, having said all of that, I think part of the problem is that Ultiboard is just too complicated for beginners. I think you can find very simple ways to do very simple kinds of things. I'll give you a good example. And if you've got a design and you want to quickly prototype something to get it to market, this is so important, because if you get hung up on something like making a printed circuit board, you're sunk. You can't make your prototype. So being able to prototype, I think, is essential to to invention. So you got Eagle, and then there's another one here which I like that I've been recently playing with, and that's called fritzing. Now fritzing gives you a breadboard view, a schematic view, and a printed circuit board view. So let's try an example here. Let's try an Arduino with the Cosmic Ray Gun, whatever. A Cosmic Ray Gun. Because what could possibly be wrong with that? Is this working? I have a funny feeling we're having issues with Open Example Arduino Digital button. So is anything working? Yeah. So there's a nice sort of graphic user interface. You can drag and drop parts. And if you go in over here at the library, you can find parts are available in through-hole, they're available in surface mount, but when you use a breadboard, it always comes through on through-hole, because breadboards can't do surface mount unless you have adapter boards. If you go through to something like the adapter boards, you can find a whole bunch of interesting and wonderful boards. Let's see if we can find a couple. Here's an adapter board. It's got a barometric pressure sensor on it. Here's one that's got a triple axis accelerometer. It's a breakout board. With a breakout board like this, you can place it You can rotate it into position, and then you can proceed to wire it up into your little Arduino. You know, how cool is that? And it's got everything broken out. But later, you're going to want to use a surface mount part, SMD, right? Surface mount device. So let's go and look at another view here. Here's the schematic. Now the schematic's a very good representation to sort of describe what's going on. And it goes straight to be consistent from the breadboard straight into the schematic. And it will even do auto routing for you in the schematic if the lines are not right, but I don't care for the auto router on this one. And now let's assume you go to the printed circuit board, and here it is laid out as a PCB. Now from the PCB you can proceed to fabricate something directly on in-house, let's say with a single-sided printed circuit board and a laser printer and press and peel work, artwork, or if you want you can send the PCB out, and you can change your design rule checker. Looks like it's good. You can change your settings to professional or homebrew. If you want homebrew, maybe you can print it here and then have it fabricated here. Or you can set up your own custom stuff. And then there should be a way to like order a board. Where that is exactly, I don't remember. Oh, here it is. Order PCB or export for PCB. And if you export for PCB, you get your extended Gerber files. You probably put them someplace. Where shall we put them? New folder, I suppose. I forgot what to call this, but let's just call it, here's some junk. So we'll put it into some junk, and now it's done, and presumably you now have to zip it for the DRC bot to accept it. And so there should be like some junk. Here it is. Here's your junk. So let's see now. That should be bottom solder, top silk screen, top, I think that's copper. I forgot what all these things stand for, but they're defined somewhere. And so presumably I can go and take some junk and make a zip file out of it. Let's see, how does one do that? Is there 7-zip on this machine? I thought we had it. Yeah, there it is. 7-zip file manager. I want a new file. Does anybody know how to use 7-zip? Well, presumably you guys know how to use computers better than me, and you can make zip files. And then you just upload it to Batch PCB. And I'd show you how to do it if I could make, you know, computers work. Computers are hard. Usually you mouse right and you see 7-zip is installed, right? But it's not here for some reason. And of course the reason it's not here is, even though I've asked like 17 bazillion times for my stuff to be installed, they don't do it. Because why should they listen to me anyway? And of course Dropbox is not responding because who knows why. So there it is, in a nutshell. The other one that I'm using, of course, is Eagle. That gives you a little bit more flexibility. Let me see if I can log in here. So now, is 7-zip in here? I don't even see 7-zip. So I have to like go somewhere and download it, I guess. What a pain. .7-zip. See, now that's interesting. Let's see how Google works. See, now Google won't work either. So this is typical. Our network, 7-zip. Download. So I have to reinstall it for some reason I can't understand. You know, why should that be? So here's the exe file, 32-bit. That should be alright, right? Does 32-bit stuff work on a 64-bit machine? I think so. But the 64-bit stuff doesn't work on the 32-bit machine, right? Yeah. Gosh, it's warm in here, isn't it? Oh, distance learning students don't have to be hot. So anyway, I thought I would give you a little insight into what it means to do crowdfunding. If you're going to do crowdfunding, you're publishing your invention. So crowdfunding becomes a barrier to patentability. So with crowdfunding, what you want to do is go through this process I just mentioned about making your prototype, make sure that it works properly, try and get it out so that you've got a little software to support it if you need it. Maybe the more examples, the better. Then it's very important that you make a video. Your video is going to be the thing that really sells your product. From a crowdfunding point of view, stuff that doesn't have a video rarely gets funded. The other thing you might like to do when you're selecting how to crowdfund your product is to decide whether it's a good fit. What I did was I hired a data miner, and we went through and we decided what would be more funded than something else. What we found was that there is a ratio that you can create in terms of the amount you ask for versus the amount you raise. When that ratio is 1 or greater, then the project is successful. If it's 2 or 3 times greater, then it's considered very successful. So the typical Arduino shield raises 3 times more than you ask for. That's very interesting because Apple products don't do that. Not Apple accessories, and even though they raise a lot of money, it's not usually 3 times more than you asked for. So this is a very interesting point. You know, you can typically count on something that if you ask for 2,000, maybe you'll make 6, you know, in terms of sales. So crowdfunding is all about pre-sales. You haven't mass-produced, but you have made limited production runs, perhaps 10. There's a big difference between making 10 boards and making 1,000 boards. Big difference. When you bring a product to market, you don't want to do a production run that's large if it's not going to sell. But you can't really bring it to market at a low price unless you do a large production run. So you're caught. You're caught because you don't know. You really don't know what the market is. And the only way to know if what you're building is something somebody is going to sell is when you offer it and see if people would, well, buy it. So what you want to do is be able to offer it but not have to deliver it. So with pre-production sales, what I end up doing is I put a target date. My target date is August. So that gives me 5 months after I'm funded, which will be in early March. So then I think, well, you know, now I've got time. I already made my first 10 boards. I've got my software. I'm ready to roll as soon as I am funded. But I need to know how many to make, and I want to make a few extra, maybe a lot extra, maybe an extra 100, just so in case I can continue to sell after this is done, because you must remember, you're not actually just bringing a product to market, you're starting a business. And the business must have inventory, or else you're just going to sell once and then you're done. And that's not good. So when you bring a product to market like this, the reason it's to your advantage is it removes the risk of production. That is, you do not want inventory sitting in your garage unsold. That's a big risk. I have a friend who did that. He has a garage full of stuff that he cannot sell. Very bad. So you're getting committed orders, and the money is being encumbered by a third party. The trusted third party is Amazon. So Amazon requires that you have an account. That's actually a big deal. When you get in an Amazon account as a merchant, then people who are buying stuff through Kickstarter will have to pay a commission, perhaps 5% to Kickstarter, and a commission, perhaps another 5% over to Amazon. So that means 10% right off the top goes to Amazon and Kickstarter just for being able to do, I'll call it, social media marketing of your product. But 10% overhead is not bad, especially if you thought you were going to have an advertising budget otherwise. So in some level, one could make a claim that's cheap. 10%, that's nothing. So you give them their 10%, and then you get access to what is probably the most popular crowdfunding site anywhere. So then you think about, okay, I've got this thing, and I've got this great idea, and I'll start to put it out there. How much time should I give it? Well, Kickstarter is all or nothing. The all or nothing crowdfunding style means you either get your funding goal or you don't. If you don't get your funding goal, you don't get any money, and you go home and you cry in your beer. And you come up with another idea. That's happened to me. This is my second try. So then, if you do get your funding goal, then you have to deliver. Then the question is, do you have to deliver on time? 4 months is the typical delay after promised delivery date for hardware. That's very bad, right? So people are looking now. They're aware of the idea that maybe you can't make what you've promised you could make. So don't just give them promises. Show them a prototype that works. Don't just give them a 3D rendering. That's not even permitted anymore. People used to just make these beautiful 3D renderings and it looks like it exists, but it doesn't. Even though it was computer created and it looks like it's got all the right, lighting and everything, it's not real. So they made it forbidden. You can't just have a 3D rendering. On the other hand, I put a 3D rendering in after they put the rule in place, and I got all freaked out because the rule came in the middle of my preparation for the Kickstarter. They allowed it anyway because I had real product. So they don't want just a 3D rendering. So now you have to kind of do this thing people call UPOD, which is under promise, over deliver. So you want to promise this thing which you know you can deliver at a certain time by which you know you can deliver it, and then at a price point which you are sure is going to make you some kind of a good profit margin. And so then you have to do the computations, and it can be done on the back of a napkin, it can be done in an Excel spreadsheet. I've done both because I have so many rewards that it got a little complicated. But what you want to do is you want to figure out how much it is going to sell for, how much it's going to cost you to make, and that includes everything, including shipping, including how much it costs to get through customs, including assembly costs and parts and fabrications and everything. Subtract the two, that's your profit, divide by the amount that you've actually sold it for, and that's your profit margin. And for me, I shoot for a profit margin of around 40%. And the reason I do that is because I need to have a little room to make mistakes. Maybe I'll make a change to a printed circuit board so that I don't go to port 11, I'll go to port 9. Or maybe I won't have 8 bits of output, maybe I'll put in a little DAC and get 16 bits to give them a little extra. Or maybe I'll put in what's called a stretch reward and I'll add some components to the device and I'll say, look, if you get to $6,000, everybody will get this, that, and the other thing. And if you get to $7,000, then you get these extra things. And you can do that if you've got some volume. So you can promise some stuff to people once you've reached your goal amount. You want to set another goal, higher goal, call it your stretch goal. And then people will help you. Now that's the other thing. The value of crowdfunding is not the funding. The value of crowdfunding is the crowd. Because the crowd will tell you about your business things you never knew. They'll say things like, how come you're not on Facebook? And then you'll answer them with stupid answers like, what's Facebook? Right? There's 2 things wrong with my doing social media marketing. The first, I don't know anything about social media. And the second, I don't know anything about marketing. So there's a big issue here when you do something like me and you're not on Facebook and you don't Twitter and you don't tweet and you're not on Reddit and you don't know what the heck is going on. But the people who are in the crowd, they do that stuff. Because a crowdfunding system is a social media marketing system, they'll help you. And you just explain it to them and you say, I don't do these sorts of things, but if you guys could tweet about it, boy, that would be great. And so other people are doing it, and all of a sudden now someone says, well, how come you're not on Facebook? I say, I'm not on Facebook because I don't know what that is. Well, you should be on Facebook. I say, okay, now I'm on Facebook. I don't have any friends. That's sad. Thanks a lot, buddy. So now I have no friends. It's like wow, the kid nobody wants to be friends with. This is terrible. So it's a big deal when you look at the people who are doing the crowdfunding and you ask the question, what makes it successful? The ones that have the big networks, Facebook networks, are way more successful than the ones that don't. And that's a big deal. So I don't have that. So it's a handicap for me. But you guys are born in a different era. You have like iPhones and iPods. I have a stupid phone. Really, no kidding. And I think 27% now of the world's population has a smartphone. That means everybody but me has a smartphone. So why am I so stupid as to not have a smartphone? I don't think I need it, but apparently, everybody else wants these things. By the way, 5 years ago, only 1% of the world's population had a smartphone. So the world is changing. And the smartphone advertising is really a big deal because if you're using your phone to see, are there any restaurants around here? That's much more compelling because you're ready to act. I'm looking for a hardware store. You're looking for it on your phone? That means you want to find a hardware store now. That's a much more valuable way to advertise. And when you look at people and they're advertising now on mobile, they don't even charge for that. A lot of it's free. So as a result, they haven't yet differentiated the product. So there's still market opportunity, tons of market opportunity. Plus, mobile smartphones are just growing like crazy. So let's think in terms of what kinds of products. I like to do the kinds of things that are interesting to me. But obviously, you'll do the things that are interesting to you. So if you said to me, I like software, I want to do a software thing, there are examples of people who do software stuff. But in general, it's all over the place. So you could do something that's just the simplest thing. Here's a part. It's a little piece of plastic that holds the keyboard against the iPad, and yeah, it looks like somebody raised some money for that, twice as much as they asked for. And here's a little clip that holds up a phone, a little plastic part. Now, I got to tell you something. There are certain costs which you can essentially take into account but not pay up front. Let me tell you about plastic. Injection molded engineering plastic has a price per pound which is equal approximately to the price of a gallon of gasoline because it is a petrochemical product. That means that if your device uses perhaps 4 ounces of plastic, right? Here it is, my plastic injection molded cup from AT&T, right? A piece of duty plastic thing, right? And so now I look at it and I say, well, there can't be more than $1 worth of plastic here, probably less than 50 cents worth of plastic. And you say to yourself, well, gee, that seems like a very low cost, and it is, but there are startup costs. If you wanted to have a case, you might need a mold for the bottom half of the case and another mold for the top half of the case. Those molds have to make it so that the top and bottom half fit, which means you need a precision mold. Well, that could be a $3,000 to $5,000 mold for the bottom half and a $3,000 to $5,000 mold for the top half. Figure spending about 10 grand just to get the molds done. What does this mean to you? It means if you're charging $11 for the coffee mug or the case, you're going to clear perhaps $10, right? And that means you need to sell 1,000 units in order to be able to break even with your startup costs. You don't even have a profit until you've sold 1,000 units. So now you've got to think about it. Wait a minute, 1,000 units times $11 a unit, I have to have at least 11 grand just to get going with my little 4-ounce piece of plastic. And presumably whatever your product is, it's got more than 4 ounces of plastic associated with it. There's probably engineering costs too. And so somebody with a CAD tool has to sit down and actually carve it all out. But let's assume that you don't want to do that until you've raised the money. Let's assume you want to prove the market first before you go spending $11,000. And by the way, I didn't even include the cost of patents. Don't even get me started. One patent agent told me he charges $350 an hour. Just to read the patent you wrote will cost you $1,750. And that's a provisional. And that doesn't even include the fees for the United States Patent and Trademark Office. And certainly doesn't include trademark costs. So now you say to yourself, okay, I've got all these things going on, all these different moving parts, and I'm thinking to myself, I don't want to spend 11 grand on molds, and I don't want to make 1,000 parts and have them sit in my garage. So what I'll do is I'll go to the 3D printer, and the 3D printer will make one. That's good enough. It's good enough for the prototype. So if you look at something like this, which is made with a sort of the Astro clip, it's made to take the camera on the iPhone and hook it up to what looks like the ocular, the objective of a, no, I guess it's the other side. The objective is the front, the back is the ocular piece. The eyepiece of the telescope, right? So this holds the camera onto the telescope. Very clever piece of plastic. So as it happens, the Astro clip could be fabricated with a 3D printer, maybe some hardware. Bang, you're done. You've got your prototype. Now you don't have to spend the $10,000 until you're sure that you can afford the molds. So the economics of plastic are very interesting. You get a very low cost on a per unit basis, but very high startup costs. And that's classic. That's a classic problem with engineering in general. You know, you need to think in terms of printed circuit boards this way too. Your printed circuit board might cost you $10, but you don't want it to cost $10 in volume. And if you've got 100 boards, maybe it only costs you $4 each. So that's a big deal. Now I'll tell you another thing about printed circuit boards. Your prototype might use through-hole like I do. I have to have holes drilled. I have to have the components soldered in place. They can't be soldered in place with a pick-and-place machine because I'm not using surface mount parts. But if I have somebody who's in Milford assembling this by hand, he charges me 40 cents to solder in an 18-cent resistor. That's a big deal. When you put in that much stuff, now you're talking about an extra $4 just in assembly costs for a $15 board. That's like a third the cost. So I'm looking at this and I'm thinking to myself, okay, this is something we could have cost optimized. We could redesign the whole board and make it all surface mount. And if you do that, then the pick and place machines can just throw it on, automated, from tapes or reels, and then presumably wave solder the whole thing, and it's practically free, right? Big cost reductions. But they are not the thing you want to shoot for until you've proved the market. So getting the prototype out there and seeing if the market is there before you go and do extra engineering to reduce costs is so important, because that's part of your startup fees. So this guy, he's got 64 backers, 48 days to go. How many days does it take? Well, you can select 30 days or you can select 60 days, and that's it. Kickstarter doesn't have longer periods of time than 60 days. I gave myself 60 days because I wanted to continue to promote this stuff, and I hadn't done a lot of work in advance. And I wanted to see if I would how it would work with modest amounts of promotional stuff. And I did very modest promotion and tried to let the crowd do most of the social media marketing. This guy will not be funded unless he has 75 grand, it says. So you got to get your prototype. You have to have a production plan. You've got to have a good video. Then, you know, some people say good, really good, hire a professional production crew. I got like kind of a crummy little video, and I think it was good enough. It was all right. And people who said, you know, they saw it said you could tell it was happy hands at home. So if I had gone to spend a great deal of money, I guess I tell you what I did. I outsourced it, and it spent about $150 to do the production. Not much, really, very little. But I could have done it myself, but I didn't because I didn't have the time. And the business plan, just plan to make money, perhaps, if you go way beyond your goal. So just look to try and break even. That was my goal. Bringing a hardware product to market for the very first time, and breaking even sounded like a good idea to me. And now at this point I can say, I didn't just break even, I'm actually making money on it. And presumably this is my first hardware product brought to market. There are these other sites which you can use to try and promote your stuff. Gizmodo, TechCrunch. You can find out where your particular project funders will live by looking at projects similar to yours and seeing where they blog. That is very difficult. I cannot get Gizmodo or TechCrunch to review my product, and I've tried. Not repeatedly. I send an email, I ask them to look at it, and maybe I try a second time. I can't get them to do anything. It's very strange. I don't know what it takes to get reviewed. Cool factor. If you've got public service associated with this, that's service learning. That's so cool. Social media will pick up on that. So a social entrepreneurship bent might be a new way to make clean water, a new way to make green power, a new way to do something that helps people, whatever that may be. You fill in the blank. So that's a compelling argument. That gives you cool factor. And then try more than once. Don't give up. Here's one called the Backcountry Boiler. He got 60 grand and his goal was 20. Turns out the Backcountry Boiler had a lot of production problems. Leaking, rusting, not being food quality. It was able to boil water okay, but it wasn't good. So there were problems. And probably this should have been better tested before it was brought to market. You get your when you have more successful projects, they get more exposure, but with more exposure, you're more exposed. Let's assume that you've got the titanium lock, as cool as your bike, right? And so here's this cool titanium lock, and you've raised $108,000. Now let's assume you can't deliver it. You're going to have a lot of angry backers. People have been sued over this. We gave you money, you promised you'd deliver, then you didn't deliver. Well, you either return the money or you send the product. You don't get a choice on this. You've been paid. So now if you can't deliver, you can get sued unless you can return the money. So this is a big deal. And some people who were not responsible, not organized, that didn't know what they were getting into, got a very successful backing and a very successful following, and then they got sued. Okay? Professor Lyons says, don't get sued. You don't like it, you won't like it, you'll wish you never heard of me if you get sued after having this lecture. So remember, I'm recording this, and I told you, don't get sued. That means keeping things on the up and up. You know the difference between right and wrong. Don't make promises you can't keep. Under promise, over deliver. Here's a good one. They made $942,000 for their little mount for the Apple Nano. Okay? Apple Watches are all the rage now because Apple saw this, saw how successful it was, and they licensed it. That's where the big money is. But they won't license it if you don't have a patent. So you must have your intellectual property nailed down. Then you've got to use your own means of bringing it to market. You can't run around licensing stuff if you can't prove the market for it. This allows others to see what the device is that you've created, what you've invented, and proves the market, and helps you create a business. Now there's a compelling argument that your license has a great deal more value. You've got the patent, you've got the product, and you've got customers. That's so much more important than just having a good idea. Customers are where it's at in entrepreneurship. You've heard of lactose intolerance? Most of your VCs are lack of sales intolerant. If you don't have sales and you don't have customers, then you don't have a business. Simple as that. So, bottom line, it takes persistence, it takes work, but there's something else that you may think about in terms of bringing something to market, and that is trying to find help. The one thing I learned as an entrepreneur is you cannot do it all yourself. But everything has to get done. So you put those two statements together, and what you find out is you can't do it all yourself means you need help. So then the question is, how are you going to get help to get everything done? Let's say you're very good at making PC boards, and you're very good at microelectronics, but you're lousy at making videos. Or you don't care to be good at it, so you find somebody who's good at it. And one way you can do that is you can go to freelancer.com, or you can go to odesk.com, and you can put out a bid to have people work on your job. I do this all the time. Let's say I don't really care to learn how to make my book into a Kindle Fire compatible book, right? Because I don't care at all about the Mobi format, M-O-B-I, which that's some Amazon thing, right? So I want the book to look right. So I put out a bid. I said, here's the book. It's 940 pages. There's a lot of work involved. It's all in Word. Make Kindle Fire happen. You know, and I get bids. Some people say it'll be a couple $100. Some people say it's a little less, some a little more, but I'm happy with these bids, so I'll just outsource it to somebody else. Let their worry. I don't want to deal with that. Same thing for the video. You know, there are certain things you're just not going to be good at. I can't be good at Barnes & Noble Nook, Kindle Fire, and whatever other e-reader of the du jour there is, right? So, I mean, I just don't know these things. Let somebody else who does this all the time for a living do it. It's much better. Some of them actually don't charge a great deal of money, and in any case, if you only need to do something once, it's much better to let the professional who's done it before do it. So, I'll give you my little demo, just so you can see where it's at. Oh, look, the zipper is here. Open, run, install, finish. Ah, good deal. So then if I go back to this thing that we created at the beginning, which was some junk, see, the WinZip thing isn't here. That's so bizarre. So how do you make a new WinZip element? You guys don't know, do you? Is it possible? How do you zip a file? You don't know. Really? How do you do that? I mean, here's right click. Now what? Oh, send to. Okay, then what? Oh, compressed zip folder. Okay, so now I've got some junk in a compressed zip folder, and it's presumably very small. And now I can go back to batch PCB and do the upload. Complicated. So here comes my product. I have to sign in again. How does one do an upload here? Upload. Model. Junk. The Junkie Test. Junkie Test 2. Do not open source this design. And then so there should be like some zip file in here somewhere. And this is it, some junk. We'll open it, submit. And are we there yet? Successfully submitted. So now you can see this is the preview of the Gerber files. So here's the drill, the bottom, the top. You know, it says TL, so it's top layer. Solder mask, that's good. Top copper, I don't need. So let's keep that out. Bottom solder. The bottom solder mask is okay. So I've got to be careful. The top silk, that could give me trouble. If you have a documentation layer, you want to keep that out. So now let's see what we got here. Let's save it. And it's queued. I suppose if I, ooh, $10. Oh, because it's a big board. I've got all the header pins in here to make an Arduino shield. Oh, and it says Fritzing on the corner. We don't need that. We should probably edit that out next time. And it passed. Ta-da! So you guys have been struggling with this for how long? Like a week, right? 2 weeks? Longer? You did it like this and it just kept failing? But when I do it, it works. Because it likes me better. So tell Dr. Munden, when will you see him next? Tonight? Today? Yeah, tell Dr. Munden, oh, Professor Lyon showed us how to do it right away and it worked just fine for him. Then what you do is you raise your voice a little octave and you say, what's the matter with you? That really bothers him. So, yeah, right, I'm very close now to making a product. Of course, I still have to go and how you say, get the parts and then put them in and do that thing with the solder. And then you have to remember which end of the soldering iron is hot. And, you know, there's all these problems with that. $10 board. That's kind of expensive, but they get cheaper by the dozen, right? I mean, this is just, you're just getting one. I wanted to show you my little Kickstarter thing, and then I thought maybe we'd take a little break and you guys could do your presentations, because I know you have presentations to do. So, HTTP colon Kickstarter, no, it's www.kickstarter, right? Starter.com. These things always take forever the first time you go there. I'm not sure why. Very slow. So let's quit out of this. Yes, we can make the change. And then we go back over here. Kickstarter is still waiting. So there's Fritzing, the breadboard. We can close. Save? Don't save? 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 No? Yes? No? Yes? No. No. Yes! So this is taking forever. So what I thought we would do is let's do the Kickstarter video after the break, and then you guys will do your presentations. So for some reason this is just taking forever. So let me stop it and we'll restart it after.